All right, all right. Welcome, everybody. I think today we have an inaugural first Shimmer stream. It's the first time that we actually have the Shimmer Network that's live and is absolutely beautiful. You know, I've been spending the last few days just like mesmerizing over the block explorer, over the visualizer, and just watching the beautiful tangle grow. And it's been beautiful just to like think about how far we've come. That we now have a live beta network for Shimmer, and that now all of you can finally participate and play around with the new tokenization framework, with the new Firefly version for Shimmer, new APIs, new client software, new wallets, right? Everything is brand new. Everything was upgraded for Shimmer, and now we can finally start building and tokenizing the world, so to say. So what we wanted to do today is with Levente from the team who's been leading the Stardust upgrade and specifically the launch of the Shimmer Network, we're going to do a sort of like deep dive into what the Stardust upgrade actually is, what it means, and actually how to utilize some of the APIs and some of the software that we have built. And we're going to do this a little bit more interactive. So if you haven't already downloaded it, download the Firefly Wallet. If you want to go even more experimental with native tokens, with NFTs and stuff like that, get yourself comfortable with the CLI wallet. I'm going to ask you during the chat to drop me your addresses so I can send you some tokens and some NFTs. And if you have questions during the show, I'll also ask, so you can ask in the live chat on YouTube. And without further ado, I think we should let Levi on. Hey,
Well,
Levi,
hello.
how are you doing?
Hello, everyone. Can you hear me all?
Great. I think everybody is like suffering from the heat.
Yeah, indeed, and it's crazy in Berlin as well. So bear with me with this heat. I hope I can cool you down with some cool new features of Shimmer.
Yeah. You know, at the end of the
Yes.
stream, we're going to be sweating everywhere because so full of energy, and we can't keep the windows open because then it just gets warmer. So let us do maybe a recap. Like, where do we stand right now? So the beta network went live, right? So maybe
Yes.
you can.
How long of a recap you want? Because I can start from Genesis and go from there. But yeah, so this week on Monday we have actually deployed the first live version of Shimmer. It's called Shimmer Beta.
Yeah.
And this is actually like we at the engineering department. You can actually enlarge that picture a little bit. So what you can see here is that we kind of defined our own release strategy for Shimmer. And altogether, we have 5 phases for shipping Shimmer software and going live with the network. So, of course, phase 1, research prototyping. I think many of you who have been following the progress could read a lot about this. I think the first time it was actually announced last year in November when we published the tokenization framework specs, because that is actually the alpha and the omega of this whole Shimmer network.
Right.
And yeah, since then we've been busy building, testing internally, also with the X teams. Shout out to them; they've been amazing. And right now we feel like we are kind of at a stage where we are confident on starting to do public testing. What this means is that we deploy the Shimmer Beta network. We basically published all the new client libraries, all the tools, a lot of documentation. Of course, not complete, but whenever you can say documentation is complete, it's never. So we published a lot of things. We rewrote the whole wiki, added versioning to it. I will show you a little bit later, but what you can take away from this is that kind of this is the most exciting time for us, because this is the time where you, developers, builders, or just people interested in IOTA can finally grab whatever we have done, test it, and start building your applications with it. I think I'm not spoiling much if I say that many projects have already been developing and learning about Stardust. of course, in stealth mode, most likely. But
Yeah.
well, if you believe me, then in the next couple of weeks we will see way more external non-IOTA Foundation projects popping up with their Shimmer integrations. So
Yeah.
I'm really much looking forward to that.
I mean, this is absolutely the biggest milestone of this year, and it's a huge achievement of you and the entire engineering team at the foundation, and obviously the community as well. And it's kind of interesting how we got here, right? So we started out with Chrysalis or Chrysalis.
It was a long journey.
Yeah. You know, one thing.
With the legacy IOTA, and then moving on to Chrysalis, then now adding Stardust, and most of you know what is in the pipeline for Cordyceps as well. So I'm not gonna evaluate on that.
Yeah, and starting with the debates if we want to keep watts or not, right?
That was a big decision.
Yeah.
But rest assured, one thing is that at least for the Stardust upgrade, users won't have to migrate their tokens. We are not going to introduce any new signature schemes. We actually, from the moment Stardust will hit the mainnet, actually I haven't talked about that, but this Shimmer Network is actually like the crazy cousin for IOTA as well, meaning that whatever we try in Shimmer and works will be pushed onto the IOTA mainnet as well. And by the time this first new package, which is called Stardust, hits on the IOTA mainnet, you as a user don't have to migrate your tokens. You just basically download the new Firefly and it works out of the box.
Yeah.
You don't have to do anything, and we are not touching any of the outputs and addresses and whatever. It's basically just upgrading all the protocol and extending it with a lot of new features. So
yeah, that's a really important point, right? So that it's really seamless going from the current IOTA to the new IOTA, or even going from, I don't know, the current Firefly Wallet to the Shimmer Firefly Wallet. Just before we move on to the diving deep session, I just wanted to have like one quick discussion about, I would say, the hidden heroes of the Stardust upgrade, right? Because I think as we start to build the open source software more in the open, right, together with the community as well, and I think we did a really great job with Chrysalis, and now with Stardust, we really took it to a next level with the Tangle improvement proposals. And I think this is really something that is worthwhile to highlight here, that all of the different changes that were made to the protocol are actually reflected in this tip process. So that means that everybody can actually transparently know how the protocol is being adapted, right?
Yeah, it's not just of course, we adapted this framework, which seemed to work for many other DLT projects as well, for engaging the community, to have discussions about technical or sometimes even stuff which is so deep that even I don't understand it to the fullest extent. But this is a great place because this is a reference for why we made the choices which we did during the development process. Anyone can come and comment and basically see what is up, share their opinion. So one thing which is not here, you are now looking at the compiled final version, but actually it's a GitHub repository where you can see everything. So if you have a GitHub handle, basically you can just come and drop in and then say hi, that we actually have a discussion forum. So if you go into the discussions there you can see that basically any change that we do, before we have an informal discussion about it, people chit chat, hey, I think this is good, I think we should go left or right, etc. So it's actually like a good way of engaging with the community and trying to make them understand why are we making the choices, engineering and design choices, which we are making at the end of the day.
Yeah, it is a much more open way to build, right? Because this way, all of you who are really excited to start building on IOTA and obviously on Shimmer, now is really the time to get involved, because all the protocol changes are being built or being discussed in the open, right? Before they actually become a tip, they are being discussed here, and everything is open, right? And so it's really good time to participate. And engage
there's a well-defined process of how, like someone proposes an idea, then we have to discuss it, then we come to an agreement on who writes the tip itself, then we evaluate the tip, we merge it as a draft, then we work on the implementation, etc., etc. So it's a nice framework to actually channel all these development efforts and try to organize them. So it's not just a huge mess.
Yeah, cool. Do you want to jump into it? Do you want to share the screen? Your screen?
Yeah, sure, I can do that. Let me see. Do you see my screen? Because I don't see.
1 second. Now it works. Yeah, now we can see it.
Okay. All right. Where to start? So maybe before we go over what is out there with this release, just a little bit of recap. So I hope many or most of you have read at least one of the Stardust blog posts, which gives, kind of like an introduction of what is Stardust and why is it such an important thing. And spoiler alert, it's important because this is the first time that we will be able to deploy and run smart contracts on top of IOTA. Which means that finally we will be able to leverage all the nice tools and applications, decentralized applications, which have been built for Web3. So Stardust makes IOTA Web3 ready, but with a unique touch. And the unique touch is actually that we are not just going to deploy yet another EVM chain, but rather we are taking the base layer, the base infrastructure of IOTA, and make it an infrastructure layer for running many blockchains on top of it. So imagine it as like we are creating a highway. We are creating a highway which is fast, which can transport goods and data and value and whatever. And the blockchains anchoring into this base infrastructure layer, they are actually not constrained by the the throughput of the base layer, but they can still interoperate. So they can send each other tokens, they can send each other data, and this brings up completely new like use cases. When, for example, imagine that one blockchain owes something on another blockchain. I don't recall that something like this has been done in the space before, but this is absolutely what is possible with the Stardust upgrade. So yeah, the core of this whole thing are the smart contracts and how we basically modified our UTXO-based infrastructure layer to accommodate for running these blockchains on top of that. I hope today I will try to do some live demonstration, and then you will see some of the features which you can use. Of course, not all, because many of these features will be used by the layer 2 solutions. So it's going to take some time until we see like user interfaces built on top of this, because actually the developers are learning to use this as we speak.
Yeah. And maybe just one important point to highlight, right? Like the smart contracts, the EVM chain, it's currently in alpha testing internally, right? With some community projects participating, and relatively soon we're going to open it up to the community as well, so that all of you can deploy smart contracts on what we call the Shimmer EVM.
Yeah, I guess it's no secret to people following what happens on GitHub, because all the development is happening in public. So if you just go to their repository, you can see every.
You can already do it. You can already play around with it.
Yeah, you can already play around with it if you're experimental, and if you have the what it takes to figure out how it works. Anyway, so one thing is which after all these introductions, let's get to what it is actually. So as I said, we've been working a lot on technical specifications, which are here in the Tango improvement proposal. You can go and check out for yourself if you are interested in how it works deeply. If not, just pay attention and I will show you some perks. If you want a little bit more help, someone who hold your hand while you venture into the unknown, I recommend you to check out the wiki page, which has been redesigned and a lot of content have been added. So, for example, let's see, if I want to learn about the Shimmer Network, I just click on Learn More, and immediately I'm at a new page which has never been here before. And it contains a lot of information about the features, what you can use, how you can use them. Also, for the really brave, there are protocol level documentation as well here. So if you are a developer and wonder how this whole thing works, just check out this. All right, so that much about the wiki. Let's move on because we are going to be constrained on time, I believe, once we start the live demo. But yeah, the Hornet Node software is the one which supports the new Shimmer network. So you can check out the new beta release. Actually, I think since Monday we have even a beta 2 release, and because some people have already managed to find bugs, which is great. That's exactly the point of the public testing. And as you can see, we have a lot of client libraries. We have client libraries in Rust, in Go, in Python, in JavaScript, in Java. Basically, many of these are compiled as bindings from the IOTA RS library, which is written in Rust, so it's kind of performant and memory safe as well. But feel free to check out any of these. The wiki also contains documentation about the different libraries. And what is more, on top of the client libraries, which give you basically an interface to work with, an interface to communicate with the network, to send transactions, to fetch whatever the state of your wallet is. On top of all this, we have built a wallet library, which is basically a stateful application. A stateful application which makes the life of developers way easier because you can use this library without knowing every little detail about the protocol and the interface, and it's abstracted away from you. So basically what you can do is you can use this library to just call it to create a user account, deposit tokens into it, send coins with a simple command, etc. And the IOTA.rs, like the wallet.rs library and all its bindings, it has bindings in Node.js and Python as well, are really convenient to use and hide a lot of the complexity.
And that's basically what Firefly uses, right?
Exactly. So Firefly is built using this wallet.rs as a backend library. So if you see a cool feature in Firefly and you want to implement it in your own wallet, well, you can perfectly do so with this wallet.rs library. One thing which I would like to mention as well is that although we built a wallet library, this is not 100% extensive, meaning that the protocol is capable of much more than the features that we have packed into this wallet.rs, but this is a deliberate choice. And the reason is that the more complicated features you want to use, the more complicated the user interaction becomes. So we, of course, realize that we as the IOTA Foundation, we have to focus our efforts on the development of the core protocol, and we simply cannot afford to build that much user-facing solutions, and we cannot afford to build applications with proper user interfaces, because there is clearly no one-size-fits-all solution to this. Therefore, where I wanted to end up with this is that if you are a developer and you have your own application using IOTA or planning to build something on it, actually, I advise you to check out the lower level libraries as well, because probably you are in a better position to know what your application needs than us. Therefore, it's perfectly fine if you build your own implementation of a wallet library, which does things differently, which uses other protocol features, which we, for example, have left out of wallet.rs. And I think we will see this, especially with the amount of the community projects which have been applying to the Shimmer ecosystem. Many of those projects, I think, will open source their own libraries, which will be like a huge boost to the overall ecosystem as well. Because we are in the business of building open software, so of course we cannot do everything, and instead of trying to force everyone to use what we think is right. We should be recommending people to explore on their own and build whatever they think is necessary for them. And of course, if possible, open source it for the benefit of the others.
Totally.
Right. So I talked a lot about the wallet library, and actually I will use this wallet library for the demonstration as well, because we have a simple command line wallet built, again, using wallet.rs library. So at this state, this is the most extensive application that you can use for the Stardust protocol features, but rest assured, in the coming weeks, these features will be added to Firefly one by one. So just a little more patience, and then even if you're not a developer, you can use these new features in Firefly as well. We have completely rewritten our network explorer as well. So you can see that it has a fresh new look, new types of payloads. Actually, as you can see, the milestone interval basically was a little bit, well, actually halved. So as you can see that the network is a bit faster than it used to be.
That was one of the main things that I noticed about it, because not even I knew about that, that it would be 5 seconds. So it was pretty amazing just to use it. It was so quick.
Yeah, and to be honest, we are even thinking about maybe lowering this a little bit more. We will have to see how the testing goes. Yeah, I mean, we will see how it goes. I don't want to make promises, but on the technical level, it would be possible to reduce it a little bit more.
By the way, can I ask you a question? Because I think this is something that somebody just mentioned. Latest blocks, right? So we moved away from transactions to blocks. Can you maybe quickly explain why that is, why we have this new terminology?
Yeah, exactly. So yeah, these blocks which you have seen here, actually, like if I go back to the visualizer, every little point on this figure is a block itself. And the reason for this is actually that we want to align our terminology with whatever other people in the DLT space use, mostly in research. So in this sense, IOTA is not a blockchain, it's a block DAG, a block directed acyclic graph, meaning that it's actually like a chain, like multiple chains interconnected, and they are building a web of blocks. Therefore, each little point here is a standalone block, which is produced by a user. And then when submitted to the network, it references other blocks, and they build a structure which is used for the consensus mechanism. And this was absolutely crucial to do before we finalize whatever is in the Stardust release, because this is the terminology which IOTA 2.0 will be using. Therefore, it just didn't make sense to continue using the old outdated ones.
Right. I remember
but this is actually setting things right. So even though it could be seen just like a renaming, but it's actually like aligning with industry best practices on how to call whatever is in your DLT.
Totally. And like instead of saying that IOTA removes the chain and removes the blocks, we can just say that IOTA is one transaction blocks, right? And each transaction is a block.
At the moment, it's one transaction per block, although I can imagine that somewhere in the future we might have more. It's not that far-fetched.
Yeah.
But at the moment, as you can see, we can sustain a lot of blocks per second. Yeah. This is actually just the testnet. So I'm actually curious to see how many thousands we can sustain in the live network.
Yeah. I mean, the important part is that we have the blocks. We don't have the chain, right? It's not that we build the blockchain, an underlying blockchain structure, right? It's just we're just using a different terminology. So instead of calling them transactions, they're called blocks, right? So there's also
transactions are still inside blocks because our technology is also a little bit distinct in the way that a block doesn't have to contain a transaction; it can contain data as well.
Right.
And while speaking of data and Stardust, actually, we made quite some changes in the protocol architecture regarding data as well. And one of the changes that we've made is that we basically told the protocol, treat any block which only has data as pure data, and then try to offload all the processing and indexing and filtering logic of whatever data there is in the network to application-specific node extensions. And why is it important? It's important because with this, we actually defined what the core services of the network are, and namely to sustain as many blocks as you can. And usually data, when published through the Tangle, it is used in some specific application. So why should the protocol be in charge of filtering and processing out this data for the applications when they can happily do so with a node extension plugin? So we actually increase the performance of nodes this way, and we can sustain more transactions, and we need less hardware resources on nodes to actually run the network.
Yeah, no, that's super important.
Yes. So where were I before you asked the question?
We were talking about
the new Explorer.
Explorer. Yeah. And
the new Explorer and blocks and stuff like that. Right. So as you can see, these blocks which are coming in, some of them are transactions, some of them are data, some of them are milestones. Actually, a block can contain a lot. Right. So I mentioned the node extension plugins, and I think when it comes to this new change, which I believe was actually published in this blog post, Hornet Node for Shimmer Beta Network. Those of you who have read it, here is described that we made this architectural change in the node software as well, meaning that only the core protocol is what absolutely and strictly has to be supported by the nodes. Anything else is basically offloaded to node extensions, so node operators can decide, hey, I want to support this or that application, I will enable this or that plugin. It's as easy as that. Therefore, what this also means is that anyone can write any application which extends how Hornet works through a quite common gRPC interface, which is called INX. So we have a well-defined interface. You can look at it on GitHub as well. Basically, you have access to all the internals of the node. And we already basically forced ourselves to move every application which was previously built into Hornet to outside node extensions. So you can see that the permanode solution, Chronicle, has been expelled from the node, so to speak. It's basically just an extension to Hornet. All the other tools that were previously baked in, like the MQTT plugin, the participation. Oh, this one is really interesting, by the way, proof of inclusion. If you have a data use case on IOTA, I encourage you to check out this proof of inclusion plugin. This is actually something which makes it possible so that you can prove, if you generate a proof, you can prove at any point in time that your data was part of the tangle at a given point in time. And it's just an API call. So it's awesome. Quite convenient. Yeah. So I was talking about these INX extensions. And the reason why I was talking about them is because of the new permanode, which is also like completely re-engineered and restructured for performance and maintainability reasons. It has a new interface as well, defined in tips. So if you want, you can check out, for example, how to spin up a node and what interface you can use to talk to it. I'm not going to go into details, but check it out for yourself. And what this enables us to do is to basically implement newer and newer features into these node extensions. You can see that, for example, a permanode supports the core node API, but it also supports historical data. So for example, if you are building an explorer for Shimmer or IOTA, then you already have a backend solution provided by us. And you can also extend it. It's open source. You can just come and propose whatever history API you want through the tip process, and it will get included. We also have analytics implemented in the permanode. So yeah, this is quite a new set of tools for developers who want to implement whatever service or application they want to have for Shimmer and IOTA. So please check out these on the wiki, on the tips, and if you have something like a wish or if you have something in mind which you want to have, feel free to just post it on the discussion forum. Okay, so much about the developer tools. Let's talk about Firefly, because the majority of the people on this call, I believe, are interested in how a normal user can use this.
Yeah, it should be noted, right? Like we always like to define also the target audiences of what we build. And for IOTA, it was always really difficult because we never really acknowledged the speculative part of IOTA and the IOTA token. And there was never real token utility. And I think with Shimmer, very clearly, the main target audience is builders, right? That's why we put so much effort on developer experience. And we have a really amazing developer experience team. And they created this beautiful new wiki, right? And are really participating also in the community. And so our big focus here is really to empower all of you to build on top of Shimmer, because that is the primary objective here. We want to have an ecosystem around Shimmer. So the developer tooling that we have is super important. We would really love to get more input from all of you on what we have built.
Yeah, exactly. So we need a community to build and tell us what to build. Yeah. And we are trying to be as helpful as we can to let you know what is out there, what can you use. Actually, it's also my personal experience by talking to the community projects that somehow we have a hard time kind of shining the light on the protocol features that we have, because we are always constrained in our thinking about, okay, but how would an end user use this? And I think we have to force ourselves to ditch this idea of thinking about how the end user would use it, because our target audience as the engineering team of the IOTA Foundation is to empower the developers who build the applications to do this. They are the ones who know how to build good user-facing applications.
Yeah, absolutely.
We are way too deep into the research and the protocol to think normally again, I guess. So yeah, these are the API endpoints which you will be able to use if you want to try it out. So Firefly Stardust. What we have today is actually the first build of Firefly that can transfer Shimmer tokens in the beta network. So I think I will start the interactive part of this. I have downloaded the Firefly Wallet from this link. Well, actually, I think there might even be a newer one if you look at the Firefly releases. Yes, beta 1.0.1. So I have downloaded this software. I'm sorry if sometimes it's buggy or you see blank out screens. This is kind of still beta software, so it's expected. Just giving you a heads up. And let's hope that the live demo gods are a little bit on our side. So let's say I will create a new wallet, which I will just call fun. By the way, is my keyboard too loud or is it bearable?
No, it's fine.
Okay, because I often get that it's too loud. So
we enjoy the sound of a mechanical keyboard.
Right. So I've already played around a little bit with it, but just for your sake, this is the new Firefly Stardust beta. It can do stuff, but as I said, many of the protocol features will be coming to Firefly in the next weeks, meaning NFTs and native tokens. But first, just the basics. So when you download the Firefly Wallet and you want to do something with it, of course, you need some tokens. So I would just click on this to copy my address. By the way, take a look at the addresses. They start with RMS. It's not an abbreviation for something. It's actually SMR the other way around. And this is because we want to make it so that if you play around on a test net, oh, someone already sent me some Shimmer. Nice. I was
That was very quick.
That was very quick, yes. And I think they know what this number means. So probably it was an inside joke. But anyway, so these are the addresses which we call bag32 addresses. It's just about the format. And they have like a human readable part, a little in this case RMS. In the live Shimmer network, this will be SMR. They have a separator, which is 1, and then they have basically your public key hashed and then coded with some checksums. Right, so actually I wanted to show how to get some tokens. And to get some tokens, first you need to go to the Shimmer faucet. This is all in the blog post, so you can check it out. You just basically copy your address here, and Shimmers are on the way, or they should be. I think it will take roughly around 5 to 10 seconds to get these, if I'm not mistaken. So let's see. In the meantime, I will create another wallet. Let's just call it AMA wallet. What I'm going to do is I'm going to transfer funds in between my two wallets. So, whoa, people started sending me a lot of tokens. You're really good at reading addresses from the screen, by the way. So what I can do is send around my funds. Now you see this new type of dialog, which was not here in the previous version of Firefly, where you can say how much tokens you send, and you can actually choose Shimmer or glow denomination. And this is something new for us at IOTA. Basically, what glow is one glow is the 1/1,000,000th of a Shimmer token. So it's basically the smallest possible denomination of the Shimmer token. So 1,000,000 glow equals 1 Shimmer, and vice versa. This is so that I can say that I want to send, I don't know, 10.07 Shimmers. I have to choose the recipient, which is my other wallet. And notice that you can define actually two stuff here. You can define metadata for your transfer and the tag. So I would just say this is payment 1 and hello from the army. And if I want to send this feature, two new things which you haven't seen before. One is the storage deposit, and the other one is the expiration time. The expiration time is a cool new feature, meaning that no matter what transfers you use, you can basically set an expiration time on them. Let's say that in an hour, my transfer should expire. So if the recipient doesn't claim this transfer within 1 hour, the tokens are basically bouncing back into my wallet. So I don't have to do any additional stuff. It's completely time-based. And this way I can be sure that if I send something to the wrong address, or if I send something to unintentionally or a dead address or zero address or whatever, I will be able to get it back in 1 hour. Now the storage deposit. Actually, if you read the Stardust protocol updates, then you probably read about our new storage deposit system. This is something which all of the DLTs have some form of protection, because if you think about it, whenever you transact via the network, all the nodes in the network have to store some information about your transactions. So the more transactions are piling up throughout the time, the more data nodes have to store. And at some point, you have to basically say, okay, this much and not more, because you cannot just always increase the requirements for running a node. And therefore, we came up with a a solution which basically caps the total amount of data maintained in the network based on the ownership of a scarce resource, which is the base token or the base currency of the network.
I mean, like the block space in IOTA, right? In the ledger, in any type of blockchain or any type of distributed ledger, is the most important and the most scarce resource, so to say. So there has to be a way to protect it, and obviously there has to be a certain like deposit that needs to be put down in order to get access to this block space, right?
Exactly. And why you say that here is that storage deposit is not required at all is because actually the transfer which I'm about to make is self-sufficient. So if I send 10 Shimmer tokens around, that means that those 10 Shimmer tokens themselves are covering for the data storage which I use. So I don't have to include anything else. Let's just send it and see what happens.
So the storage, like just from my understanding, the storage deposit is really relevant for data, right? Because there you don't have any tokens that you're transferring. It's relevant for other tokens that you have. Like if I have a native token, like the Dom coin that I made in the wallet, I also need to have a storage deposit, NFTs, right? And then in the future, also the smart contracts that anchor into the ledger.
Yeah, exactly. So actually, like this data, with the Stardust upgrade, there will be two ways to store data in the network. One is if you just use the block without the transaction, you just basically publish data through the Tangle. But these data blocks, so to speak, they are, after some time, they are pruned away by the nodes because they are not part of the ledger state. What Stardust innovation does is that you can actually put this data and embed it into the transfers themselves, meaning that if you hold the tokens, of course, the network is not going to forget your tokens, but next to your tokens, your data is safe and always available on all nodes as well.
Yeah.
So how the storage deposit actually is the opportunity cost, which you actually pay for forcing the network to store that data. But what is great is that if you decide you no longer need that data, you basically burn that data and you get back everything. So you still don't have to pay Shimmer tokens for storing your data. You just have to lock it up for the time that you want to store the data.
And for those of you who are really interested in tokenomics, like this is one of the main token utility features of Shimmer and of IOTA in the future.
Exactly. Like if you think about it, the more tokens are created and the more data is actually stored on the Tangle, the scarcer the token becomes, the token value becomes. So that means that if we provide utility, that also means that we increase the scarcity.
Yeah.
Right. So you can see that I have this incoming transfer in my AMA wallet. I could reject it. I could claim it. Right now, I'm going to claim it. So transaction claimed. So
can I ask you a quick question? This is something that I've been wondering about. So I received a transaction, right? And it has to be claimed. And how does that work then? Like, do I then from my wallet send a transaction to claim it with the right signature? Or how does the claim process actually work?
Good question. We can actually see it on the Explorer how it works. So I just clicked on that button and actually I claimed this transfer. In the meantime, someone sent me again some Shimmer tokens. So I'm going to be a Shimmer whale by the end of this talk, probably.
By the way, this is very impressive that they're able to do that.
Yeah. So if I just copy my address and I go on the Explorer, which tab is it? This one. I simply look for my address. Now, what you can see is that this is my address. This is the hash of my public key for the tech-savvy people. Am I in advanced mode? Yes, probably I am. I can see the transaction history.
Yeah.
And you can see that I've used this address before. But this is actually which is the claiming transaction. So if you see this one, no, sorry, not, this was the claiming transaction. So what happened here? This is a transaction, which you can see. It has some fields, and the content says that it has some inputs, meaning stuff which I consumed in the transaction, and it has some outputs, which I created from the consumed inputs. So if I look at what was this was actually coming from another transaction, and it was coming from this transaction. This was the one which my fun wallet created. So my fun wallet actually created an output to the address of the recipient, but also defined that this other address, which is the own address of the wallet, can take these funds if we pass this time. And you can see that when my little message with a typo and the tag here. So this is what I've created in Firefly. And then when the recipient gets this, they actually, the recipient notices because that's their address. So when the recipient gets this, then they create a transaction which consumes this and sweeps it into their own wallet. So you can see here is a transaction ID being spent in transaction. So if I look for this, I will arrive back at the previous transaction which I was looking at. And what this did is actually just swept this output and the 10 point whatever shimmers into the wallet, the other wallet. So I ended up with owning a basic output with only an address unlock condition. So it's fully mine and no one can take it away from me. Only my wallet can unlock it because my wallet is the one which controls this address.
No, it's an absolutely amazing feature, you know, like being able to define these time locks and it can be claimed.
Someone is, I'm gonna reject it, sorry.
You have to test the protocol.
Yeah. Okay, so one more thing which I would like to show with Firefly, and then we will move on to the hardcore developer stuff, is how you can actually send small amounts. So I mentioned that from my original wallet, a lot of people are just going to 0 SMR. What is it? Received 0 SMR. No, I'm not going to take this. Someone is, actually, I don't have to create a transaction because what you can see here, what I wanted to demonstrate is what happens when you send small amounts. So this is, for example, one glow, which you can see. Somebody's trying to send me one glow, which is 0.000000000 cents probably. So in other networks, no one would bet an eye on taking this. So, and of course, 0.0000001 shimmer is not enough to cover for the storage of this data storage of this transaction. So what happens is that this address who sent me this said, I'm going to send you one glow in a transaction. And in that transaction, I'm going to include a storage deposit of 46,000 glow. But if you want to claim it, you have to send this back to me. And you can only take this amount here. So that's what I'm going to do here. I'm going to claim it. And now, if I go back to the Explorer, and my address, which was, where was my address? Here. And I look for the most recent transactions. Well, I'm not sure I'm going to find it. But believe me that what actually happened 7 minutes ago, 6 minutes ago, maybe if I have to refresh it again. Still loading, yeah. Here is it, a few seconds ago. Was it this one? Yes, this is one, I think, which is, no, this is not that one.
I mean, you have to pay, yeah.
What I was about to show you is just simply the fact that I had to refund the storage deposit to whoever sent me that. And this happens in the claiming transaction, and the protocol enforces that this absolutely must happen. So it's completely safe to send small amounts with such constraints on the transfer, because the recipient cannot do otherwise. The protocol forces the recipient to refund your storage deposit. And
so you basically you basically receive a micropayment, and you have to include a storage deposit for the micropayment to be transferred. But in order for the recipient to accept it, they need to send you back the storage deposit. So for you, it's basically you get back the storage deposit and you didn't pay a fee, so to say.
Exactly. Yeah. So maybe I can claim another one, and then we will see. It's just that I don't think, it doesn't work for me on Linux, this button. Okay.
I think you can copy the claimed in at the bottom. Can you copy that, like the claimed in?
No.
Oh, no. Yeah,
no, but I can copy the address. So if I just go and look for the address, the recent transaction a few seconds ago, this is it. So this is a transaction. As you can see, my wallet generated this transaction from my address. And what it did was basically consumed the conditional transfer, this output, and also some funds which I owned in my wallet. And then with this basic output, I actually refunded whoever this address with the storage deposit. So if you look at the exact amounts here, this should be, this is, you see, there is a 1 at the end. So I just sweeped 1 glow into my wallet and refunded the other person.
That's awesome.
And I didn't pay a fee first, so it's quite nice.
It's just beautiful how it works, I must say. Yeah, and then I remember how much time you guys spent in thinking about the storage deposit, and how much of a breakthrough it was as well, right?
Yeah, it was quite some time until we figured this out. All right, so that is actually what I can show you right now with Firefly. So for the developers or people who are not afraid to look at a command line wallet, I actually prepared some stuff, meaning how you can mint native tokens and how you can mint NFTs. So let's try and do that. By the way, do you see, or is the font size enough?
I can see it. Maybe you guys can say something in the comments if you can see the terminal window.
I'll take it.
Maybe just start and then I can tell you if they.
All right. So what I have here, well, going back to the release notes, what I have here is actually this CLI. I've downloaded this command line wallet, this one. You can see the releases here. I've downloaded the latest one, this Beta 4. And I'm going to show you how you can actually mint tokens with this. So let's get started. First of all, I've set up 2 wallets. So let's go to wallet 1. I've already initialized it so that we don't spend much time with that.
By the way, maybe you can make the font a little bit bigger.
All right.
Thanks. Francis, yeah.
Is this bigger now?
Yeah,
better.
That's good. I think that's good.
Right. So I just entered the CLI wallet application, and I've already created a profile which is called Fun. And now we can actually see whether I have something or not. Well, it doesn't seem like I have stuff. So let's just list my addresses here and fund it with some Shimmer tokens. And now we wait until it appears on my balance. I really hope it does. Yeah, there it is.
Nice.
So I just received some coins from the faucet. If I type in the help comment, you can see all the available comments in this command line wallet. So you can list your addresses, check your balance, do stuff with native tokens, with NFTs. You can consolidate your funds, etc., etc. You can even send micropayments. So what I would like to show you is this native token stuff. So if you have read the blog post, then you know that in Stardust, anyone can mint coins or tokens into the ledger. So you can create Dom coin, I can create Levy coin, or whatever. It's finally here and happening. The way you can do that is that you have to deploy a foundry on the protocol. And once you deploy the foundry, from this foundry, you can mint new coins and melt coins in the foundry and transfer coins in and out of the foundry and whatever. This is just going to be a simple demo. So I'm going to say that I'm going to mint native tokens. And as the int tells me, I have to actually set what kind of supply I want to mint. So let's just mint 1 million. And then comes another new feature of Stardust that basically I can link my token metadata on chain to the foundry. So I don't have to host metadata about my token on some IPFS server, whatever. If I'm willing to look up some tokens to cover for the storage, then I can just host it directly on chain.
And what, maybe just so people understand, what do you mean with metadata here specifically? Like
I'm about to show you right now.
Okay.
So yes. No, sorry. So if I go into here, I already prepared some metadata. So if I look at, for example, token metadata.json, usually metadata is like a JSON file adhering to some whatever metadata standards, which contains fields like the name of the coin, the description, symbol, the decimals, the URL where you can find out more, and the logo. So I'm going to mint some Shimmer Talks token right now, which I believe are going to the moon after this talk, but we will see about that. So to be able to link this metadata, since now we are developers, we need some way of linking it. So what I did is I basically took this JSON file and converted it into bytes. So if I look at the token metadata text representation, these are basically the bytes which make up of this JSON there. I'm going to copy these. And I'm going to go back to where were I? In this wallet, yes. And I'm going to just paste it here. Once I hit enter, I have to wait a little bit. Actually, now behind the curtain, there are two transactions happening. One is deploying my foundry, or actually one is deploying an alias which can control my foundry. And the second one will actually create the foundry and mint new tokens. It's going to take, it's happened already. So let's look at the transaction on the Explorer, what happened. Here, no. Can you guys help me? Which one is it? This one. So this was the transaction which minted my coins. And you can see that not only I created basic outputs, it created a foundry and an alias as well. The reason for this is because while we were designing this whole tokenization framework stuff, our hypothesis was that if smart contracts and blockchains running on top of IOTA cannot act as token issuers, then what's the point? Like that's the huge thing when you say a smart contract chain, a blockchain itself can act as an issuer on layer one. Why is it such a good thing? It's because whatever assets are held inside the blockchain, you can program those assets to be locked up and basically wrapped into a layer 1 representation, which can then travel freely across the Tangle to other blockchains. So in this sense, we are kind of introducing a new way of composability and cross-chain composability, which makes it possible to migrate your assets and tokens from one blockchain running on top of IOTA to another blockchain running on top of IOTA without any complicated bridge solution, because the protocol itself will be the bridge which does this wrapping and unwrapping and whatnot. Anyway.
Yeah, I mean, this is really one of the most important features of Shimmer, right? This composability between the different layer 2 networks that's not possible anywhere else. So it's definitely something really, really important to highlight.
Exactly. So these alias outputs, these are basically the accounts which we created for smart contract chains. And the foundries themselves are always controlled by these aliases, meaning that a smart contract controls what happens to the foundry on layer 1. So it can be programmed to do whatever. Anyway, let's look at this foundry output, which we have just created. And what you will be able to see, actually, there's one thing which you won't be able to see. I hope it worked, but I'm not sure why it doesn't show it. Anyway, this is a foundry on protocol level. You can see that it has minted this many tokens, it hasn't melted any, this is the maximum supply, etc. And it has some data linked. Now I wonder why I cannot toggle here the JSON representation. But anyway, if I just copy this and I go to some online tool and say, convert this hex string, convert this hex string into text, well, it's not going to work. So probably I have mistakenly put something there. But
it's all immutable, basically.
Yeah. Anyway, believe me that this is actually the data which I have put there. And in a future iteration, you will definitely be able to see the JSON representation of this. Maybe I'm just going to give it another try and see if I mint native tokens. Oops. Token, let's say I'm just going to mint 100.
Yeah, I mean, one of the comments was just to remove the spaces of the hex string, by the way, because there was spaces between.
Oh, were there hexes?
No, not here. I think on the Block Explorer.
Okay. Like one thing which I'm not sure if I need that 0x at the beginning. Yeah, I do need it.
Yeah.
Where are we? But one thing which we can try is actually, let's see if this is my node, by the way, so please don't DDoS it or whatever.
Too late.
Too late. But what we can do is we can take a look at this transaction in that Explorer, which was the network ID, transaction ID here. Yes, and let's see what happens when we see this metadata here. Well, probably I mistyped something, but yeah, it's similar. or UTF-8 coding doesn't really work, but you can see that if I made it correctly, then this would have been the data which is there.
And I mean, this is really important, right? Like you can have a token and you have metadata that's tied to that token, and that metadata can never change, right? And that's not really possible anywhere else. Because if you think about it, right, like an ERC20 is a representative of a token. It's not a native token as the Ethereum token, for example. So these tokens, they're natively on the ledger, right, on the layer 1. So that means that they're as scalable, they're as fungible, They can be transferred across the entire ecosystem, right, between different layer 2 chains and so on and so forth. And you can always have this metadata reference to it. And that's really huge. So you always know, like, what does this token actually represent? So if we mean tokenize everything, you can really tokenize everything with this one.
Yeah, exactly. Like, these tokens are tracked in the very same ledger as the base currency. So if you look at an ERC20 token, what it does is actually you deploy a smart contract and creates a ledger inside the ledger. Therefore, the outside, it is blind to the outside world. With such tokens, with these native tokens, basically these tokens are living and existing in the very same ledger as the IOTA ones. All right, so let's speed it up a little bit. So I'm just going to, actually, Dom, can you send me your address? Somehow I'm going to give you, send you all of these tokens. Well, not all, I'm going to keep some for myself, but I'm going to send you some tokens so that you can distribute it to the alert viewers.
Should I read it out loud? Wait, how should I give it to you?
I don't know, send me on Slack.
Through the metaverse.
Or in the chat, like you have a chat here in the...
I can't type in this chat for some reason. It's kind of weird. Wait, I'll send you on Slack.
All right.
Did you get it?
Yes. So now everybody's going to know your address. So if I type in the send native token command, then it tells me that I need to give it an address, need to give it a token ID and an amount. So I'm just going to send native tokens to Dom. Well, sorry. In the meantime, I lost your address. But let me copy. Yes. The token ID, well, I can see in my balance that I have token ID of this. How much do you want? I have, how many zeros is that? It's that, that's 1 million. I'm just going to 900,000. You have to claim it, and then you can start sending it out to people.
Why do you have to claim it, by the way?
You have to claim it because the way this CLI wallet works is that it forces you to use the storage deposit return feature when you send native tokens. What I could have just sent you these 900,000 coins plus 0.01 Shimmer to cover for the data deposit, but I want to hang on to my dear Shimmer tokens or Shimmer Beta tokens. So you have to put up the storage deposit yourself for it. And let's see if you manage to claim it or not.
I'm still in the process of...
So here is the output which Tom is about to claim, I believe. Yeah, you see, I just sent you some native tokens with this token ID, 900,000, and there is a storage deposit return condition and an expiration. So you have time until tomorrow to do this. Anyway, I'm going to move forward in the meantime because I think we are already, 1 hour, 10 minutes into the call. Right. Another big feature or another feature of this wallet, if you list out the comments, is you can not only mint native tokens. Of course, you can melt and burn, but it's not that interesting right now, so I'm just going to skip it. You can also do this with NFTs. So to mint an NFT, it tells me that I need to give it an address and I need to give it some immutable data. So this is going to be data which is tied to the NFT and no one can ever take it away or fake it. So this is the proof that the issuer put this here. Right, so I'm just going to, well, actually, I'm going to mint it to your address, Dom.
Yeah.
You use the CLI wallet to generate the address, right?
Yep.
All right, and then I'm going to mint this NFT. Well, no, I'm going to mint to my address, and then I'm going to send you as well. So I have this address here, and I'm going to mint an NFT. This address, I have to define then the immutable data. And for this, I actually prepared already, similarly to the native token metadata. We also have metadata for NFTs. Let's say NFT1.json. The native tokens, as you can see above, this was defined in the so-called IRC30 standards. For the NFTs, and they are defined in the IRC27 standards. These are all tips, so you can go and read them. Well, I will leave it to the viewers to find out what kind of meme this is, but this is actually an NFT, will be an NFT from my meme collection. You can see that you can link these NFTs together via features. I'm not going to go into details, but let's just say that this is an NFT which will have a much low factor and 70% love coefficient, and it is very rare. I already prepared the hex metadata for this. So let's say NFT1 metadata.
By the way, a quick side question. How much metadata can you actually store? Like, is there a limit?
Right now, there is. So right now, in one output, you can store up to 8 kilobytes of data.
Yeah.
2 times, actually. So worst case, 60 kilobytes. If you have immutable and mutable data, for example, for an NFT, then you can, but in general, it's 8 kilobytes. In the future, I can imagine that a future protocol change is actually going to increase it, but it's always the same block space discussion. So this is kind of a middle ground, and I have rarely seen NFTs which have more data linked than 8 kilobytes, so it should be enough.
Yeah, that's good.
All right, so let's just copy this metadata here and mint an NFT, and let's say with this metadata. And the transaction happened. So let's see the transaction on the Explorer. What you can see is that my wallet consumed some funds, and actually it needed to deposit 0.18 shimmers into the output. It minted an NFT output. Now the NFT output itself has some properties. And the properties are that has its own distinct address. This address here is actually an address which is owned by this NFT itself. So this is what we mean when we say that in Stardust, NFTs can function as standalone wallets or can own any other asset in the ledger or on the AirTools as well, is that because right now that I minted this NFT, it basically got a unique identifier, an address from the protocol, which functions as my regular signature-backed address. So you can send funds to this address, and you can consume it with the NFTs, whatever. So let's just look into what the beta is here, and if I manage to do it right this time or not. Do you remember where was my online tool? No. Anyway.
Which one are you looking for?
I'm looking for the text hex converter.
Oh.
This was it. Right, the 0x is definitely not needed. Oh, now this time it worked. I managed to do it. So if I convert this one back to a JSON, you can see that my NFT is here. Has anyone already managed to open this link? or open the transaction. If not, I will let you Dom do this.
Yeah. So all of this is according to a standard, right? IRC 27, I see there.
Exactly. It's according to a standard. So the native token metadata was actually deployed with the IRC 30 standard. There's a tip for it. I encourage you to read it. It actually defines what fields can be here, what is the validation of these fields, what are the necessary ones, what are the optional ones, and of course, you are free to propose your own or extend it as you wish if your application needs something else. So there was one for the token metadata, native token metadata, and the other one for the NFTs. It's coming from the community, as you can see. It's called IRC 27, and the community who came up with this proposal actually wanted to add richer features into the metadata. Therefore, they implemented a collection ID system, a royalty system, modeling and modular design. So, for example, if I look at this data which I have created in the IRC 27 standard, well, maybe better if I go back to, oops, sorry. If I go back here, you can see that we have a field which is called royalties. So if I were to go and sell this NFT on a platform, on an NFT marketplace, then, for example, the marketplace would know that 0 or 2.5% of the sale price would have to go to such a royalty address, and no one can change this. This is immutable. Another thing is that this collection system, which you can read more about on the wiki, in short, it's basically just links together NFTs via a protocol feature which we call issuer. Therefore, you can create collections where one dedicated NFT, the collection NFT, is actually governs, or the collection NFT governs the minting of NFTs within the collection. You can lock it for some time. You can actually destroy it, burn it, whatever. Therefore, you can be sure that your collection will never get diluted. And, again, something which increases the scarcity of not only the IOTA token or the Shimmer token, but also of the NFTs inside that collection.
Yeah, no, it's absolutely amazing. And I think I really love this concept that you can think about NFTs as a wallet, right? So each NFT can actually own another NFT. And so thinking about just GameFi applications, you can really take this to the next level. Right, really
definitely.
So that's really beautiful.
Unfortunately, I cannot demonstrate right now this NFT wallet functionality, but in code, I've seen that. I've seen that it can be implemented. It's just not part of the CLI wallet yet. Yeah. But if you go into one of the client libraries, you will see examples how to do that.
Yeah.
Okay.
Cool. No, okay. I think that sounds really amazing. I still need to claim the tokens, by the way.
Okay, I'm just gonna send you the NFT as well, right?
Yeah, send me the NFT.
So I will send you the NFT as well, and then you can.
Maybe you guys send us your address in the YouTube chat, and we're gonna send you some tokens after the show or during the show.
All right. So I'm going to send this NFT. I have to tell what address I want to send it and which ID. I see that I have this one here, so I'm just going to send it to you. And you should have it.
And here again, the same process, right? So basically, we need to claim it.
I'm not sure, actually. Because if I look at this transaction, and if I look at the NFT output itself, the NFT transfer, since like the immutable fields are not allowed to change, therefore, until you burn the NFT, you won't be able to get the storage deposit out of it. Therefore, the CLI wallet actually just send you the ownership of this NFT without any further unlock condition. So it's fully yours. You don't have to claim it. Although if some wallets decide that they want to, treat it as a refundable storage deposit, then they can also do so. It's just that in this sense, the storage deposit is inseparable from the NFT. So the only time you can get it out is if you burn it. Therefore, it doesn't make sense to always swap it. You just treat it as part of the asset.
Makes sense. And obviously, the NFTs will also be integrated into Firefly, so you will be able to see those.
Yeah, sure. It's going to take some testing, but it's already on the way. So
maybe you can show it in the Explorer, what it looks like.
The NFT itself.
Yeah.
Well, you can see that here is the NFT. Here is the NFT output itself. So basically, on protocol level, that's how it looks like. If I wanted to show, you mean to show the JPEG which this NFT represents? Or wasn't that your question?
Yeah, exactly.
Okay, let's say open link in new tab. This was actually one of the memes from an internal presentation, because this whole journey of native tokens and coins started with colored coins. That was the spark that ignited also the IOTA smart contract revolution or building that solution. And we just iterated on this idea until we basically ended up with unlimited shitcoin minting with Fundries.
Yeah, no, that's really funny. Yeah, it's funny. It's funny how far we've come, and absolutely amazing work. Maybe we spent the last 10 minutes talking about, or 5 or 10 minutes talking about the roadmap and what's next. Or do you have more? Do you want more to show?
No, it's fine. I think I will just send some other stuff to the addresses which you put in the comments after this call. But yeah, let's talk about the next steps. So as you can see, well, why can't I just open this in the new tab? So as you can see, the release strategy, we are currently in phase 3, public beta testing, which means that we would like to invite all the developers to start building their Shimmer integrations so that we can figure out all the remaining bugs and all the things which we, of course, cannot do on our own. And the only way we figure out what is missing is if you start building integrations and you organically try to use the network, and because that's when we will figure out if you need something or not. Of course, the protocol itself is tested for semantic correctness, but I'm fairly confident that it's going to function properly and work well. So right now there are some things which need to happen from the technical side to close the beta testing. We would like to carry out stress tests as well, mostly internally, to benchmark where is the edge or where is the limit of our software, what kind of parameters do we have to use in a production setting, how to tune, for example, the difficulty of submitting a transaction, or what exactly the storage deposit requirements will be. So these are the technical considerations which we still have to evaluate in the coming time period before we can actually say that Shimmer is released. And another kind of requirement for the release, I would say, is that I personally wouldn't feel confident launching something before at least some community projects verified that their application works on top of Shimmer Beta, because that is actually like a good signal that everything works as intended, if something is tested by users in community projects. So these are the stuff which has to happen. And once that happens, then Shimmer will be launched. Basically, you will just have to download the new Firefly Wallet and all the, well, we are not going to do the same mistake with the Ledger Nano integration as last year with Prism. So I can tell you that the backend is already developed and in review by the Ledger team. Therefore, only the UI part of this Shimmer claiming process. What I mean is the reward claiming process from the staking, IOTA staking. So that's what has to happen. And of course, the Shimmer supply vote should be concluded as well, because it's also a technical requirement that once we launch the network, it will be way harder for us to modify or actually change such basic parameters as, for example, the base token supply. So I would expect the vote to have been concluded by that time as well.
Totally. Yeah.
And once Shimmer is live, of course, we will see a myriad of projects popping up. In the meantime, I expect ISC to come out of internal alpha testing and continue with beta testing in a public manner, which will pave the road as well for Shimmer EVM. And yeah, actually, once we have that, then whatever is remaining is basically some small tools for bootstrapping the IOTA network with the Stardust changes. So that I'm pretty confident will happen rather sooner once we have Shimmer live.
Yeah. So basically testing. So all of you who
and organic testing. So I mean, like we try to write test scenarios, and we have test scenarios ourselves, and we write tools to test our stuff. But at the end of the day, it's the usage by real people which counts, because that's how you figure out if you are missing something.
Yeah, I mean, to all of you who are asking when, please test, right? Try and claim tokens of other people. Try and do weird things, right? Try and break things. Because at the end of the day, I think one important point to highlight, right, is the fact that while Shimmer is meant to be a staging network for IOTA, it's still a layer one, right? It's its own network, its own layer one network, has a layer two even, right, with smart contracts. And so we cannot just recklessly launch Shimmer and hope that it will work. We need to be absolutely sure that Shimmer is safe and secure so that you can actually have your assets there, because the Shimmer is most valuable if it's actually valuable, right? If there's tokens listed on top of Shimmer and dApps that are running on top of Shimmer that have value. And in order for them to have value, all of us need to have confidence that Shimmer is really safe, that it's secure, that it has been audited, right, which we've already done. And it's really a new layer one network to be sort of like this innovation testbed. And so I can really encourage all of you to participate in this testing. Maybe some important things also just to reiterate is Firefly is basically going through this iterative development cycle right now, where they're going to add some new features like the tokenization framework and also NFTs and obviously Ledger support. And then we're going to do testing around the claiming of Shimmer tokens, which will be a very interesting thing. And in addition to that, with smart contracts, that should also come out over the next few weeks, so that all of you can actually deploy your own smart contracts on top of like EVM, Solidity smart contracts on top of that EVM chain, and also interact with the layer one and with Firefly. Maybe as a last showcase, I can also show. Can I quickly share the screen?
Sure.
Yeah, because so basically, the way that the integration is going to work is that we have Firefly, and then you will actually use MetaMask with the smart contracts. And the team has already been working on the integration there, so it's all working pretty nice so far. It's kind of amazing to see how you do a transaction on the layer 1 and it then pops up in the Shimmer wallet. Oh, sorry, in the MetaMask wallet. All right, so we're getting very close to the release of smart contracts, but then again, that also needs to be tested, needs to be vetted, and be ready for the mainnet release. Let's maybe talk, like there's some more questions that I'll quickly answer on the forum. What exchanges will support Shimmer from the get-go? I think that's up to the exchanges. We're already communicating with some of them. The exchange guide is done. And
yes,
I think
there is a guide to how to integrate for exchanges. So from this point on, it's basically up to them if they decide.
Yeah.
And when.
Yeah, I think one of the most beautiful things about Shimmer is that wherever IOTA is listed, it's very easy to do the Shimmer integration as well. So there's not much work to do. Let me actually share the screen here so that everybody can see what I'm reading. What would you say is the time frame of the Shimmer mainnet launch for it to come to the IOTA mainnet? Do you
mean the time between Shimmer launch and the IOTA Stardust mainnet upgrade?
Yeah, exactly.
Well, one thing to, once the Shimmer network launches, of course, it's going to take time to pick up some usage from the community projects and to actually have something usable. So I wouldn't rush as soon as possible to IOTA, because what's the point of pushing it out to the IOTA just for the sake of having it if the applications or the apps are not ready yet? So realistically speaking, I can think about,
timeframes. Yeah.
Timeframes. Well, I don't know, because whatever I say, it's not gonna come through, and then at the end of the day, people will reference this video that I said that it's gonna take a couple of weeks, and at the end it was a couple of months. So not sure what to say, but one thing which I can tell is that once Shimmer is live and applications are stably running on top of it, then it's just a question of some small bootstrapping tools for deporting the new protocol.
Yeah, I think one important point to highlight is we definitely need to give time for the Shimmer ecosystem and for Shimmer itself to also develop and evolve, so that we can also really fully test everything, because it is quite complex, right? Going from a layer 2 smart contract chain to layer 1 and so on and so forth. And so maybe one thing that we should also aim at doing with Shimmer is to sort of launch multiple smart contract chains and really see how they interact with each other as well. So I don't think there's any concrete time frame. I definitely think we want to upgrade IOTA mainnet this year. And so other than that, right now the focus is really on Shimmer and making sure that all of us, especially all of you who are listening, right, that we do enough testing, we build our dApps, we build our tokens, we have some fun selling them around.
Okay, someone is asking there, what special features there are in the Shimmer EVM?
Yeah.
So I guess it ties back to the special features of IHC, IOTA Smart Contracts, because that's the name of the technology that will power the Shimmer EVM.
Yeah.
So, it's an open source technology. Once IHC is out, anyone can spin up their own chains if they want. And one really interesting special feature for me is the built-in randomness. So from your smart contracts, you will be able to query basically randomness. You can implement whatever casino games or randomness-based logic there. That's one thing which is absolutely a new stuff. And the other one is that direct.
By the way, which is really useful for oracles, for dApps that require like random functions, like for example, poker apps, right?
Yeah.
And those type of applications. So all dApps actually need to have this random function. Otherwise, they always source it externally, which is quite expensive.
Should we have a lottery as well on-chain lottery when we launch that? I think I would like that idea.
We can have a spec lottery.
Spec lottery. Yeah, that's actually. That's actually.
Somebody should build it. Come on, this is an initiative here.
Yeah, and another big feature of the IHC tech is that from within the EVM chains, you have access to sandbox functions, which actually expose you all the layer 1 functionality. So the thing which I did today, minting tokens, minting NFTs, whatever, you will have access to a sandbox from within the EVM smart contracts in Solidity to call the same functions which I just called now in my CLI wallet application.
Yeah.
That's something which
awesome.
is kind of unique, I think.
Totally. I think some other points that are really worthwhile to highlight is that we've worked on optimizations of the EVM. So it's going to be more scalable than other EVMs as well, while still being compatible, right? You can just port over your smart contracts. Another thing is we're already looking into this multi-chain future, right? So we are going to deploy multiple EVMs that will then be able to interact through IOTA. Initially, we'll start with one EVM, right? A Shimmer EVM, but that can actually grow to multiple EVMs. So we're not going to hit the same scalability bottlenecks as other chains.
Yeah, I mean, for me, one of the most exciting stuff as well about this is that anyone, any D app can just decide, okay, I'm just going to launch my own application chain. And it still has full compatibility with the rest of the ecosystem, because by going through layer 1, they can actually, like post transactions, get data, whatever.
Yeah.
They can use whatever other features there are in the other chains.
Yeah, this composability is really key. Here's a preview of what the Firefly upgrade with the tokens will look like. How did
Levy coins there?
How did you get that, by the way, Matthias?
I send the Firefly team. Probably they are distributing it in my name.
That's funny. So here's where you can then see all of your different coins, right? All of your different assets that you have. Maybe one important thing that I wanted to highlight as well, right? So just today we had the announcement, I think it was today, right? I'm losing track of time. We had the announcement with multi-chain, and I think it was yesterday, actually. Yeah, it was yesterday. And that's a very important announcement, because what you can actually do then when Shimmer is live, you can bridge your IOTA tokens to the Shimmer network and then participate in the entire ecosystem there. So here, even though it's a Shimmer wallet, you're also going to see like wrapped IOTA tokens, and then you can earn yield on them and all of the exciting stuff. So that's going to be very good. And we're going to definitely educate all of you a lot more on what it actually means to use that bridge. And what is the difference between immutable and mutable metadata?
Yeah,
do we actually have mutable metadata?
Yes, we have. And that's a really important stuff, because mutable metadata means that basically you store data inside a transaction, and the next time you basically spend this transaction, you can just forget about the data. And why is it good? Is because that's the way that you actually communicate between the layer 2 blockchains. If I if I want to, for example, let's say I have my Firefly wallet and I have some Shimmer coins on layer 1, and I want to trigger, I don't know, execution of a smart contract on Shimmer EVM, what I will do is I will create a transfer to the Shimmer EVM layer 1 address. And in that transfer, I'm going to include metadata, which says, hey, Shimmer EVM, it's me, please execute that smart contract with these parameters. And once I post this transaction, it confirms, and Shimmer EVM chain picks it up and knows, oh, here is a request coming from someone on layer 1, and it just executes whatever I put there in the call data. And this call data is actually put in the mutable metadata part of an output. While if you have the immutable metadata, then you define it once on minting. So for an NFT, you can define it. For a foundry, you can define it. And you just define it on minting, and then it cannot be changed at all. So it's good for historical reference, so to speak.
But that sounds really awesome. So basically, like I have a smart contract on layer 2, and I want to transfer that asset to another smart contract chain, routing it through the layer 1, right? Exactly. So that means that this smart contract chain now makes a transaction with the mutable data, metadata, data block, whatever, and enters the call data, right, of the smart contract of the other smart contract chain. Oh, wow.
That's how it works on technical level. So
Yeah.
Basically, you just encode whatever you want to call. Like imagine it as you wrap your Ethereum transaction inside an IOTA transaction.
Yeah.
And the Ethereum transaction itself is sitting in the metadata.
Yeah. That sounds beautiful. Will Shimmer launch with any core design improvements, or is it startups for now? When can we expect core design updates on Shimmer?
Right. So the long-term plan is that Shimmer is going to get one by one all the modular components from the core design research or the core design prototype. That process is going to go through the same tip process as we have done with Stardust. So to answer the question, you will see once those specifications and discussions pop up on the tip forum and on the tip repository, you will be the first to know when these features are set to debug on Shimmer.
Yeah. So basically, as soon as we're done with Stardust, we'll start working
exactly.
on it.
As soon as we're done with Stardust, and yeah, I mean, we internally are already working on these modular components. So it's basically the research team is eagerly waiting to start participating in the development process once the developers are not busy with Stardust anymore. So I would say that's the next step after the Stardust update.
Yeah. That sounds good.
And by the way, just one thing which I want to point out, this whole Stardust and extended UTXO model stuff, it actually came from the core design research. I was part of the team for 1.5 years working on Go Shimmer with Hans and Jonas and the other guys. And that's where we first prototyped what you see today as Stardust. So we actually took that prototype, worked tirelessly on making it into a proper specification, and then basically porting it to Shimmer, launching it with Shimmer and then porting it to IOTA. So technically, to answer your question, the first core design component is Stardust, and it's gonna be live on Shimmer soon.
No, that's awesome. Will we see?
Love you, Angelo.
Yeah, I love you from Angelo. It's trending. Will we see activity on Shimmer Beta? By the way, the community always complains how I say beta. I always say beta instead of beta. I said it in German.
No idea how it should be pronounced.
I mean, of course, we're already seeing it, right? And there is definitely also going to be some integrations from Suniverse, I think, right? And many of the other dApps, they're obviously waiting for the smart contract chain. They're already deploying it in the test net, like also like the alpha net of the IOTA smart contracts. And yeah, it's definitely coming. Can we stake our Shimmer tokens yet? Not yet.
The answer is no.
No. Can we expect a distributed coordinator until core decide on Shimmer soon? That's something that we are looking at, but there's no definite answer to that yet, I would say.
Yeah, you always have to look at all the options before you make a architectural design decision. So
yeah, exactly. And so Shimmer will launch with a coordinator, and then we can see how it progresses from there. Yeah. Cool. No, I think that was super enlightening. Thanks a lot, Levi. Like that was really, really awesome.
Well, thank you, and I hope I wasn't that deep into the developer hole, so that most of you on the call could understand it as well.
Yeah, like that.
It's been quite intimidating to see so many stuff happening on the command line, and we are kind of lacking, as I pointed out in the beginning, we are lacking the nice, shiny, fancy stuff. So
yeah,
that will come with time for sure. But first, the basement has to be built before you can build a roof.
Yeah, absolutely. And we needed to have this solid foundation with Chrysalis, and now we have Stardust, and it's so huge, right? Like everything that's included there, and there was so much thought put into it, and you can really hear that when you speak, right? When you explain the alias output and how it actually helps the layer 2 transfers, and it's really like a protocol upgrade that takes into account this future iteration of IOTA, which is to go multi-chain. right? And we have this new utility with smart contracts on top of IOTA, but we will be able to take it a step further and scale to this multi-chain future. So thank you very much for this very enlightening session. And I hope that all of you who are listening, that it's a funny meme. Hope all of you who are listening and who are developers, like, please use our libraries, please explore, please try and break things, right? Right now, we're really in the phase where we need to have as much input as possible. And then the more we do, the faster we get to our Shimmer tokens and can take this to the next level and create some very exciting opportunities for all of us. So thank you again, Levi. And obviously, thank you to everybody who has built this amazing Stardust upgrade at the foundation and also at the community. You're all awesome.
Well, thank you for hosting me, and a huge thank you to the whole engineering team, and also many of the departments I think were involved in the IF, and also a lot of people from the community. So
yeah,
hats off to all the people who were involved. And yeah, it's a significant milestone which we have reached with Shimmer Beta, but I don't want us to stop now. So let's go full steam ahead to the Shimmer launch and eventually to a Web3 future with IOTA.
Yeah, let's go Web3. Cool. Awesome. Thank you, Levi. Have a wonderful evening. Hopefully it's going to be a little bit colder.
Yeah.
All right.
Bye-bye. Bye-bye.
Thank you. Bye-bye.